Hello students, once again I am here with the continuation of class 10th mathematics chapter 1 real numbers. Already we had two classes of this chapter real numbers. Today we are going to discuss one more theorem of related to real numbers. Before I come to that theorem, let us discuss one very simple thing that is studied by you in very small classes, that is factorization. All of you know that composite numbers can be factorized, and factorization occurs in two types. It can be prime factorized and only factorized. I hope all of you know what you mean by prime factorization. The factors which are only in primes. Which are the prime numbers starting from the lowest 2, 3, 5, 7, 11, etc. So there are composite numbers which can be factorized into primes. Say for example, I am taking a composite number, say 500. 500 is a composite number. This number 500 it can be divisible by the first prime number, that is 2, and the answer is 250. So when we divide 500 by the lowest prime number 2, the answer is 250. Now this 250 is again divisible by 2, and the answer is 125. Next prime number 125 is divisible by the next lowest prime number, that is 5, and the answer is 25. Now this 25 is divisible by the next prime number, that is 5, and the answer is 5. So the prime factorization is over. 500 is a composite number. It can be divided by the first prime number 2, this is the answer, then the next prime number. If it is not divisible by 2, then we will try by 3. If not by 3, then we will try by 5. So we can say 500 is factorized as, or 500 can be written as 2 into 2 into 5 into 5 into 5. These lower ones are the prime factors. So 2 into 2 into 5 into 5 into 5 are the factors of 500. Such an arrangement, the way in which I have written or I have drawn this prime factorization is known as factor tree. This is known as factor tree. This type of factorizing a composite number is known as factor tree. So what did you learn from it? Every composite number can be prime factorized, which is known to you even from the smaller class. Now we are going to study it in the form of a theorem, and that theorem is known as fundamental theorem of arithmetic. I repeat, fundamental theorem of arithmetic. So fundamental theorem of arithmetic is nothing but, the statement goes like this: every composite number can be prime factorized, and this prime factorization is unique apart from the order in which they occur. What does it mean? So fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic states that every composite number can be prime factorized, and this prime factorization is unique. What do you mean by unique? It is same if I do or you do or anybody do, the answer will remain the same. That's why we say this prime factorization is unique apart from the order in which they occur. That means when I do, I may do starting with 2, and when 2 gets over, then we have to try by 3. Then you have to continue with 3 until and unless it is not divisible by 3. Then only you have to try with 5. So, if that order is not followed, then my order and your order of prime factors may change, but the answer will remain the same. That's all. Or in simple words, fundamental theorem of arithmetic states that every composite number can be prime factorized. Got it? Every composite number can be prime factorized. There are some more in the statement. And this prime factorization is unique apart from the order in which they occur. Its overall meaning is only this much: every composite number can be prime factorized. Now, this prime factorization method is also used for calculating the HCF and LCM of two numbers, 2 or more numbers. And you might have done it in smaller classes again. Prime factorization method is also a method for finding the HCF and LCM. I will come to that method while doing the questions given in the exercise. But I would like to teach you one more important thing, one more important rule. If A and B are, if small a and small b are any two positive integers, then there is a very important relation. The relation is that HCF of A and B into LCM of A and B. That is, product of their HCF and LCM will be equal to the product of the two numbers. This is a very important relation. If A and B are two positive integers, then their HCF into LCM, or the product of their HCF and LCM, will be always equal to the product of those two numbers. That means HCF into LCM equal to A into B. Remember this one very important point. It is applicable only for two integers. If there are more than two integers, this rule does not exist. This rule will not be true if there are three integers or more than two. It does not exist. It is only for two positive integers. Remember it. The rule is that if A and B are two positive integers, product of their HCF and LCM will be equal to the product of the two numbers. Now, I am moving to the exercise. That is exercise 1.2. Question number 1. Express each number as a product of its prime factors. You might have done in class 4th. Simple prime factorization. First one, 140. I am doing one number just for your experience. 140. Do its prime factorization. It is divisible by 2. 70. Divisible by 2. 35. Now it is divisible by 5, and the answer is 7. 7 is divisible by 7. The answer is 1. So you have to continue the prime factorization until you get the answer 1. So 140 can be written as 2 into 2 into 5 into 7. Now you must learn one thing now. Now you have to express the prime factors in power form. We can write it as 2 power 2 into 5 into 7. That's all. It's a very easy thing. You have done it in smaller classes. 1, 2, 3, 4. 4 more numbers are given in question number 1. simply do the prime factorization of the given numbers, but express the final answer in exponential form or power form. Remember this. Question number 2. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. Yes. I told you the relation LCM into HCF equal to product of the two numbers. Now you are given certain numbers to verify this rule. So question number 2, first part, numbers are 26 and 91. So you have to find the HCF, LCM and verify. In order to find the HCF and LCM, the only thing that we have to do is do the prime factorization of both the numbers. 26, it's oral, can be written as 2 into 13. 91 is also oral. Do you know the factors of 91? Which are there? 13 into 7. 91 is divisible by 7 and the answer is 30. So we got the prime factors. 26 is 2 into 13. 91 is 7 into 30. No more powers, so this is the final expression. Now, how to find the HCF? In order to find the HCF of two numbers by prime factorization method, first of all you see which are the common factors. Here you can see 13 is the common factor in both the numbers. 2, 7, they are not common. 13 is common in both the numbers. So HCF is the lowest power of the common factor. Lowest power of the common factor means here there is no question of lowest or highest power. 13 means 13 power 1. So for 26 and 91, 13 is the common factor. I told you lowest power of the common factor. What does it mean? If there was 13 into 13 into 13, means 13 power 3 and 13 power 1. Then also we will take only 13 power 1. That is lowest power. So here the HCF is 13. Now how to find LCM? For LCM the rule is, first of all, take the highest power of the common factor. Here lowest and highest are same, 13 power 1 in both the places. If there was 13 3 times and 13 2 times here, then for LCM we would have taken 13 power 3. Got it? Here there is only one time, so LCM is 13 along with all the remaining factors of the first number and the second number. So first we have to take the highest power of the common factor, then all the left out factors of first number and the second number. So we will take 2 also and 7 also. Now multiply 13 into 7 is 91, 91 into 2. 182 is the answer. I hope this is clear to all of you. So do the prime factorization of the given numbers. For HCF, take the minimum power of the common factor. For LCM, highest power of the common factor and all the remaining factors of first number and second number. I will do one more example, then you will get more idea. So we got HCF and LCM. Now we have to do the verification. What is the verification? LCM into HCF must be equal to A into B. So let's do LCM into HCF. LCM into HCF is equal to 182 into 13 is equal to 182 into 13. Two, 3, 6, 6. Okay. Now we are going to find the product of the numbers, that is A into B. A into B means 26 into 91. Do 26 into 91. See, that is also 2, 3, 6, 6. So it is verified. So we can write, therefore, LCM into HCF is equal to A into B. So this is verified. This is the method how to find HCF and LCM, and here we have proved LCM into HCF of two positive integers is always equal to the product of the two numbers. I will do one more question, then only this lowest power and highest power will be clear to you. I am doing the second question also. Question number 2 is, the numbers are 510 and 92. 510 and 92. 510, prime factors of 510. First, divisible by 2. Then it is divisible by 3. Now it is divisible by 5. Seventeen is a prime number, so 510 can be written as 2 into 3 into 5 into 70. 92. What are the factors of 92? Divisible by 2. 46. Divisible by 2. 23. Divisible by 2. No, 23 is prime number. Is it? So 2 into 2 into 23. Now, what is HCF? Or 2 into 2 into 23 can be written as 2 power 2 into 23. Okay? Now for HCF, what is the rule? Take the highest power of the common, take the lowest power of the common factor only. HCF is the lowest power of the common factor only. 2 into 3 into 5 into 17. Everywhere only 1 times. Here 2 power 2 into 23. So only 2 is the common factor. 2 and 2 power 2. Lowest power is 2. So HCF is 2. Now LCM. For LCM I told you, take the highest power of the common factor. So this time, among 2 and 2 power 2, what will be taken? 2 power 2 will be taken. And all the remaining factors of first number and second number. What are left out here? So 2 is gone. 2 and 2 power 2, 2 power 2 is taken. So now don't consider 2. Which are remaining? 3 into 5 into 17 are left in the first number, and what is left out here? Into 23 is left out in the second number. Now you may multiply all these numbers. This will be the LCM. Then you do the verification. LCM into HCF and A into B. LCM into HCF will be equal to A into B. So please complete this question. Then there is one more question. Question number 3. Do it as homework. Now question number 3. Question number 3 is, find the LCM and HCF of the following integers by applying the prime factorization method. 12. First one is 12, 15 and 21. Very simple. Instead of two numbers, now we are given three numbers. Method will remain the same. Take the first number 12, prime factorization, 2 into 3. 2 into 2 into 3 can be written as 2 power 2 into 3. 15 factors are 3 into 5. Then 21, 3 into 7. Now for HCF we will consider the common factor. Now which are the common factors here? Common factor is only 3. There is a 3 here, 3 here and 3 here. So HCF equal to 3. Other than 3 there is no common factor. So HCF is 3. Now for LCM what is the rule? Highest power of the common factor. Here the highest power is only 3 power 1, that is 3. All the left out powers, from here we will take 2 power 2. From here we will take 5. And from the third one we will take 7. Multiply them together, that is the LCM. For three numbers there is no relation. So find the HCF and LCM, that's all. You are given two more questions. Please do it as I did. Very simple. Do the individual prime factorization and remember the rule for HCF and LCM. Now question number 4. Question number 4 is, given that HCF of 306 and 657 is equal to 9. Find the LCM. So, we know the relation HCF into LCM is equal to A into B. So here A and B are, so let A is equal to 306, B is equal to 657. HCF is given 9. LCM is to be find out. What is the relation? We know that HCF into LCM is equal to A into B. Therefore, LCM is equal to A into B upon HCF. Put the values. A into B means 306 into 657 upon 9. 9 and 306 can be cancelled. Thirty-four into 657. Two, 3, 3, 8. So that is the answer. So it is simply an application of the rule A into B equal to HCF into LCM. HCF is given, A and B are given, so LCM equal to A into B upon HCF. I think it is clear to all of you. So that's all for today. The first topic was factor 3. When you do the prime factorization of a number in tree form, it is called factor tree. Then we have studied fundamental theorem of arithmetic. It is simply every composite number can be prime factorized. This prime factorization is unique apart from the order in which they occur. Then we have studied the relation HCF and LCM of two positive integer will be always equal to the product of the two numbers. Then we have studied how to utilize prime factorization method for finding the HCF and LCM. For HCF, take the lowest power of the common factor only. Lowest power of the common factors of all the numbers. That is HCF. For LCM, highest power of the common factors and all the remaining factors of all the numbers. I hope it is clear. Please do practice and ask your doubts if you have any in the comment box. Till then, take care. Thank you for watching me. Bye bye.